Hello everyone. In this section we are going to learn about React.memo and the useCallback hook. This concept is about implementing performance optimization. Memoization is a term used in computing for optimizing the performance by storing the results of expensive functions and returning cached results. So this is what memoization is all about. By using the use callback React memo, you practically improve the performance. You make sure that the components are not rendered unnecessarily. Too much of technical jargon, which I can understand. Certainly it is injurious. So let's practically try it in React with React.memo and use callback hook. We are going to optimize the performance, but for that we are going to create one application whose output is going to be like this. So to begin with, I have some predefined code here where there is an app component which has two states. The one is counter and the other is the flag. This counter is a numeric state and the flag is a boolean state. Now I want to display a header here and a footer. So I'm going to create two components whose name is header component and footer component. So I have created two files, that is the header c.js and footer c.js. These two are going to display the header and footer. Let's also go through the header.js file. Here is the header component file where I am just using an h4 to display the header section. There is no logic I have written here. It is just there to display. The important point you need to notice here is I have added one console log which is displaying a message in the console that the header component is rendered. So let me just import this header component first. I'll say import the header component from header c.js, and this component I want to display here. So I'm going to say header c and that's it. Let's also observe the output together. So we have the output here. Similarly, for footer, I have this footer c.js, that is footer component.js, where I am just showing a function and also the h6, but I am specifying some style also. I have given some inline styling, which anyway we have discussed in previous sections as well. So you can get it that how you can apply the inline styling. Important point to notice here is in this component also I have given a message that is the footer component rendered. So every time there is a component rendering happening, the console log, the respective console log is going to be displayed. Let's go back to the app.js. I'm going to import the footer component as well. So I'll say /footer c. That's the file name. And I'm going to display this footer component here. The next thing is that we do have this counter and flag. What I want to implement here is I want to display the counter with a component, and even the flag I want to display with a component. So for that I'm creating one component called display counter and one more component for display flag. Now these two are just presentational layers, so they are going to display the counter and flag respectively. Let's start coding it. I'll open the display counter.js for your reference. Here also I am doing the same thing. I have the function display counter, which is a component which receives the props. So whatever is the value of counter, that I'm going to receive in props, and this also displays console log and the message that is the display counter component is rendered. It is just a display layer, so I just want to import this. Let's import the display counter from the respective file, and let me also use the display counter component here. So now it should display the value of the counter, but the problem is I have not yet passed that value as an attribute. So in the display counter, I am using a property called props.counter, which certainly I can write here. So I'll go back to app.js, and here I'm going to define the counter property, that is the attribute, and I'm going to pass the CNT. So now you see that we have the counter getting displayed. Similarly, we have the display flag, which is going to display the value of flag. Let me also show you the display flag. Here I'm using the flag property. So that's the name of attribute we are going to receive here. Going back to app.js, and let's say, let me first import it, display flag from the respective path, and here we'll have the display flag component where the attribute is going to be flag, and you're going to pass the m flag here. That's it. So now we have both the counter and flag displayed. Just to display this output, now there are 4 components. Let's just add one more component which will change the counter and flag. I want that there has to be a common component. So that component I'm going to create is a change state component, which will change the counter or flag depending on what value you pass. So let me do that. I have one component only, that is change state. Let me open the change state component coding. So here we have this component where there is some styling applied, which is okay. The first statement in all the components is a console log and the rendered message, which is fine. And in this component, I'm taking a button and applying some inline styling. And on click, we are just calling the click event. So this is just a simple component, a button component, which I have configured, which you can reuse. So now the next thing is that I'm going to import the change state component from again the respective path. Now let's add change state here. So I'll say change state. There is an attribute called caption where I'm going to say change counter. And for this button, let's take another button now. This will change the flag. All right. So I hope you get the idea about the entire structure. There are components for everything. Each and every job is defined or done or handled by different components. Now comes the tricky part. If you observe the change state component, I have configured the on-click event of the button, and here is the caption configured. The next thing is I'm going to apply the click event. So I'm going to say click, that's the custom event for the change state component. And inside this, let's say I'm going to call a function called change flag. That's the function I'm going to call here. Similarly, let's take another event for the counter, and here I'm going to say change counter. Here I'm going to type the change counter is equal to, this is going to be an arrow function where I can simply say set count, and here we can set the value. Similarly, I'm going to configure the change flag, and here I'll try to set the flag. So the flag will be, let's say, whatever is the value, we are going to negate that value. That's it. Let's try to run the code now. Here you see that every time you click the respective buttons, it changes the respective states as well. Now I just want to show you the problem here. We have many components which you have already seen. Let me open the console for once. There are no messages at the moment, that's fine. Now I'm going to refresh the screen, see what happens. It says that header component is rendered. Yes, absolutely. The display counter component is rendered. That's fine. Display flag is rendered. That's also fine. Then the change counter, because CS render says that the change state component is rendered. Second time also CS rendered is displayed because this change flag is rendered and the footer is rendered, which is fine. When you load this application, these components are rendered, which is absolutely fine. Let me just try to change the value of counter. Now if you observe, first time the message was still the footer rendered. When I clicked on this change counter, it actually changed only this portion, isn't it? In spite of that, for every component the console log is executed. That means for every component the render is executed. This is where the problem is. This is where you need to optimize so that when this counter is changed, it should not call the header render, maybe footer render, or even the flag render, isn't it? It should render the respective component only. So when we put multiple components, this is the scene, and this is where we have to use React.memo and up to certain extent use callback. So now when I click on the flag, it does render footer, header and everything. When I click on the counter, it does render the all other components as well. How do you resolve this? This is where memoization can help you. The only thing you have to do is, let's say at the moment footer, header, everything is getting executed. What you should do is, when you export the component, the only thing you have to do is you just have to add React.memo here. So this will not be called unnecessarily. Let's add this first of all everywhere. I'm going to add this to footer, React.memo, to header, React.memo, to change state also. I'm going to say React.memo, which will do the memoization. Display counter, display flag. Let's add this here also. Now I guess we are done with all the components. So now we have implemented memoization, that is React.memo. Now let's try to observe the output. So when you reload the page, certainly all the components respective render is called. Now let's try and see whether do we have the next render getting called or not. See, I am clicking on just the counter. Click. Now if you observe, after the last footer rendered, there is only the display counter render called. Even not the flag component render is called. So now it is calling the right render method only. Let me just change the flag. Now if you observe, only the display flag rendered called, not the display counter render called. So here everything is running fine now, but still there is one issue. And the issue is, because we are using the same component for both counter and flag, it is calling this component twice, even when I click on the counter or when I click on the flag. So you see that only the respective component rendered is called, but for this change counter and change flag, which is actually one component, it is getting called twice. This should also not happen. How do you resolve this? This is where you can use the useCallback hook. So now we want that this change counter and change flag, whichever is clicked, only for that particular entity, the change state should be called. For that, what you can do is, you can simply call this related function using the useCallback. useMemo or useCallback, they do the similar job. They have a different syntax. So here in this site, as it says that pass an inline callback and an array of dependencies. So we are going to do that. If you observe the syntax, here it says that the useCallback, where you pass the function and the dependencies, is equivalent to useMemo, have an arrow function, and then you pass the function and dependencies. We are going to try this with the useCallback. Let's go to the coding. This is where I have to use the useCallback. Again, I am repeating what was the problem. The problem was all the components were getting rendered unnecessarily, which has been stopped by React.memo. But when you have the same component, still it is getting rendered for other states as well. If you want to stop that, along with React.memo, I'm going to use the useCallback. And this function which I'm calling, I'll put inside a callback. So the first parameter is the inline function which is there. The only thing I have to add is the dependency for which this has to be called. So CNT is the state which you have to look for in this case. And here another callback I'm going to use for the flag dependency. So I'm going to say mFlag. That's the state name. That's it. Now let me just refresh. Now you see that for every component, header, display counter, display flag, change counter, change flag, and footer. Let me just change the counter value. Now if you observe, after footer, there is a display counter called because this component is rendered and this component is also rendered. So only once the change state rendered is called. Same goes with this change flag. If I click here, there will be two calls. That is the display flag component rendered and this change state for the flag is called. So this is what memoization is all about. By using the useCallback React.memo, you practically improve the performance. You make sure that the components are not rendered unnecessarily. Now let's talk about relative questions. The first question is, what is memoization? Memoization is a term used in computing for optimizing the performance by storing the results of expensive functions and returning cached results. So this is what memoization is all about. By using the useCallback React.memo, you practically improve the performance. You make sure that the components are not rendered unnecessarily. The second question is, how will you apply memoization? So it's very simple. You just have to use the React.memo around the component like this. You just say export default React.memo and the component. That's how you do the memoization for each component.